mostly here on the board. So I'm going to raise the screen. This is our topic. It's called ERD. By the way, if you know of any upperclassman who's interested, we have a DBA position for local companies looking for someone to fill that position, DBA database. And obviously, they would prefer someone who's taken 310 and beyond. So, if you know of anyone, please let me know. ERD stands for Entity Relationship Modeling. Now, the first half of the class is going to be focused on modeling. And in a database, our main objective is to model data so that they can be stored and retrieved, so that redundancy may be reduced to a minimum. So today we're going to give a very, very basic introduction to the fundamental concepts and constructs in modeling. And you've studied, you've taken 199, so you understand that one of the major problems for people trying to learn how to program is the set of discrepancies that exist between how we humans operate, right, and how a machine thinks and operates. So what you have to do is that given a set of business requirements, what you have to do is to map the business requirements onto constructs, onto modeling constraints that a machine can understand, right, or operates under. And in our case, we're going to be using the entity relationship modeling approach. And what's a relational database? Relational database. What is a relational database? What do you think? Yes?
Maybe something that tracks like trends and such in different areas.
Okay, that's what it might be used for. But from a technical perspective, what's a relational database in your mind? Yes?
It's a database that has links from different fields and files to other local files.
Okay. Closer. Any other definition of a database? Relational database. Yeah.
It's a database that allows you to link different tables together in order to use them at the same time and form like a relationship between the tables.
Okay. All right. So those two are correct. Right? What you said was not wrong. It's just that it was what the database is used for. So a relational database, one simple way of thinking of a relational database, of defining a relational database, is to think of it as a collection of tables and the relationships, both of you mentioned that exist between the tables. Right? So a relational database is nothing but a set of tables plus the relationships that exist between the tables. So we know what a table is. We've all seen what a table is, right? The customer table we showed in Chapter 1 has a set of attributes, and the assignment that you did has a set of attributes. And usually, the attributes logically belong together, such as the attributes for a student: name, ID, address, phone, and so on and so forth. The examples, of course, in the book, or in the assignment, that example is a bad example of a table, because you have several different sets of things that were lumped into one physical table. And that, as a result, as you probably have stated in your assignment, that results in redundancy, right? And redundancy can lead to problems. So therefore, a table is usually defined as a collection of records that logically belong together, such as a set of students, a set of projects, a set of employees, and so on and so forth. So we're going to focus more on relationships. Okay. there are three types of relationships. There are three types of relationships. The first type is the so-called one-to-one relationship. In other words, you have two sets of data, and they have a one-to-one relationship. The second is called a one-to-many relationship, which is the most common type of relationship in a relational database. It's a one-to-many relationship. In other words, we'll explain this much further later today and, of course, throughout the semester. And then there is a third type, which is many-many. Now, just about everything that we do in a relational database has to be modeled using one of those three types of relationships. And you have to do that, and because that's what a relational database is defined. So let's look at the one-to-one relationship. And in the process of introducing these relationships today, I'm also going to introduce you the visual symbols that are used in VCO. And I hope you have downloaded VCO, because the third assignment will be VCO based, which will start next week sometime. Right. I have posted online under course documents a link to how to install SQL Server if you are ready to do that. It's a YouTube video. It's pretty straightforward, I think. But if you have any questions, please don't hesitate. You can bring a laptop by the office, and we go through that every semester. Usually, there will be a couple of students who, for one reason or another, mostly the setup on the laptop, have trouble doing that. So just bring it by, and we'll go through that. Anyway, a one-to-one relationship, and I'm going to give you an example of this. And we're going to have department. Okay, department. Please note. And department is a table. And the name of the table is right above. And department ID is the unique identifier. And one thing that's important that we will summarize by going through the slides in Chapter 2 is that every table needs to have rows that are unique. In other words, you're not going to have two rows that are exactly the same in the same table. Okay? No repeating rows. That's one of the definitions. And how do we ensure that? We ensure that by introducing a unique identifier for each row. So a department would have a department ID, a student would have a student ID. So your data, your attributes, wouldn't be in the PeopleSoft database here if you're available twice or more than once. And then, of course, you would have other attributes. We would have just one or two, maybe, right? And that's how you would visually represent it in VCO. And then you will have department, and then you will have faculty. Faculty will, of course, have also a unique identifier. Let's use faculty ID. See how I underline the unique identifier? And that's how VCO also does it. And then you will have faculty name. And most likely a bunch of other fields. And I don't know if you have, I've seen some of these databases, and an employee record, they very well have up to 30, sometimes more attributes. You'd be surprised at how much information that an organization captures. Interestingly, if you go to Google, laptop, they're protesting censorship today. Going to department, faculty, and you have a one-to-one relationship, please note, between these two tables. And the relationship we use is chair. Right? In other words, what it means is that each department has one chair, and each faculty member may be chair of only one department. Right? So in that sense, it's a one-to-one relationship. Now, it is a one-to-one relationship once again because each row in this table may be related to just one row in this table. And each row in this table may be related to just one row in this table. That's why it's one-to-one. Right? To give you an example, I'm going to draw, I will explain those symbols. Department. So this is the actual table itself. Department ID and department name. And need another field. And the other field is chair ID. Okay. So the department also has chair ID. All right. So you have faculty as a table. You have faculty ID, faculty name. All right, let's have some faculty. Faculty number 1 is 1. Faculty number 2 is Zurado. And faculty number 3 is Stout. Okay. And faculty number 4 is Faulkner. And of course, there are others. Right? And department ID, we also use 1, 2, 3, 4, for example. And department 1 is CIS. Okay. And the ID, what do you think will be the value that goes in here for CIS department? Who's the chair? Faulkner, right? So you would place 4. Okay. And the second department is accounting, and you would place 3. No, yes, 3. That's that. And there are other departments. All right. So you may very well have a database that contains just 2 tables and 1 relationship between the 2 tables. Right? So this is a relational database. This is the diagram representing the design of the database, and this is the actual database itself. All right? I want you to see that we have a relationship between the 2 tables, and it's called a one-to-one relationship. One-to-one. It is one-to-one because each row in this table may be related to just one row in the other table. Okay? In other words, a department may only have 1 chair. Now, you say, why? Well, that happens to be the business rule. You may have at some other universities where each department may have 2 chairs. And then, of course, it's not a one-to-one relationship anymore. But it so happens that here at U of L, right, we have only 1 chair. And similarly, when you define a relationship, you have to define it both ways or describe it both ways. So that we say each row in this table may be related to just 1 row in this table. And here we say that each row in this table may be related to just 1 row in this table. In other words, if someone is a chair, then he's a chair of 1 department only. 1 and 1 only. Right? But he doesn't have to be the chair. I'm not a chair. Zrada is not a chair, right? So you don't have to be a chair. And that's what this sign means. It's an optional sign. So to a row in the faculty table, department is optional to it. Right? Department is optional to it. You know what I'm saying? So department is optional to faculty. In this relationship, what department is up. So between the two tables, you may have more than one relationship. In this case, we just have one relationship. Right? Questions?
That symbol, is that a 10? It looks like a 10.
It's a vertical bar followed by a circle.
Okay. The other symbol, is that not optional? Is that like required? Or?
That means that to a department, you have to have a faculty member as chair. So that means it's not optional. It's cardinalities. These symbols have actually a meaningful, but I don't want to get into them today because I don't want to done too much stuff on one day. Because I just want to talk about this enough so that we can do the assignment. Any other questions? Okay. You give me a one-to-one relationship.
The students in classes B, none.
Okay. You corrected yourself. Anyone else? A one-to-one relationship?
Person in the CEO or like the COO, things like that.
Okay. That CEO and company, and that's one-to-one, I agree. And another one that I think that's very similar to this, that can happen, is, of course, manager and store, right? Usually you have one manager for one store. And so, but those are examples. One-to-one relationships are less common than one-to-many relationships. That's what we're going to go to next. So, one-many relationship. Okay. So what's a one-many relationship? A one-many relationship is a relationship where for one side, each row may be associated with many rows in the other table, but from the other table, each row may be associated with one row. It's one many. Given that very crude definition, can you give me an example of a one-many relationship? Yes.
Professors and courses they teach.
Professors and courses, which I think is mostly correct, because here at least at U of L, have you taken classes taught by more than one professor? You have? All right, so it's mostly correct, right? Maybe in Steph's experience that has been the case, right? And but I know that in the School of Business we do have some MBA level classes taught by one professor. So it could be the case. Any other example of one-many relationship?
Bank accounts.
Okay, you have to have two data sets, two tables.
One person can have multiple bank accounts, but a bank account only belongs to one person.
Right.
Okay, so customer and accounts, right? Okay, so that certainly could be true, but I just created an account at Chase, and the account belongs to both me and my wife. And my wife later on went and created another account, right? So that would violate the one-many relationship. So they do allow many relationships. Each customer may have many accounts. Each account may be associated with more than one customer. Any
Telephone numbers? to people, because people have more than one telephone.
My home phone number is associated with,
It's the same problem.
and then I have more than one number, right? We have a cell phone. Yes.
Say something maybe like mammals, and there's many different types of mammals, but each mammal is only.
Mammal type. Okay. All right. Anything else? Let's do something that we are all very familiar with. Look at this relationship. Course, right? What's a course? CIS 310 is a course. CIS 320 is a course. Okay. So we have the course table and course ID. Okay, I'm going to course name and maybe other things. And class or section, like some people like to probably use section. Now, a course is actually just a definition, right, that exists in the catalog. But the course may be offered many times, even in the same semester, like CIS 300. We have tons of those classes. So you have class ID, and among other things, you're going to have section number, right? And you're going to have what? Yeah, year. Yes. Okay. We'll introduce professor later on. But you would have year, right? And semester. And other things. And now, most importantly, you're going to have, this is a class, in other words, is an offering of a particular course. So it is a one-many relationship in that each row in this table may be associated with many rows in this table. Maybe, right? In other words, there are certain classes that have never been offered, such as CIS 666, right? We have reserved that for special occasions. So, but each class is an instance of a specific course, but only one specific course. You with me on that? Okay. So I'm going to do the same thing. You have course, and you have course ID, course name, so I'm going to use integers, and course name, you may have CIS 310, CIS 300, CIS 320, CIS 410. And of course, and for class, you would have, oh, I need more fields. And class ID, you have section, here, and course ID. So you may have class ID as 1, 2, 3, 4, 5, 6, and so on. They're unique, right? I indicated that this is a unique field. In other words, you're not going to see the same number more than once in the same table. That's why it's unique. And So let's say we have 310 was offered in 2010 and semester of fall, let's say, and section 01. And 310 again was offered in the spring of 2011 in section 01. And 310 again was offered in the fall of 2011. And 01 actually is offered twice in 2011 fall in the 7th section of 76. Right? And you can add sections of other courses easily, right? Do you have any questions about this? This seems like second nature to me. Do you have questions? Okay. This is called. You're already awake. All right. So green. This. No, it's not green. This is called primary key. We call them PK for short. So this is also a PK, primary key. What's a primary key? Primary key is a field or an attribute in the table that uniquely identifies each row of the table. That definition is below. And this is so-called foreign key, or FK for short. And what's an FK? An FK is an attribute in one table that relates the row in that table to another table, right? And the FK usually is a value that's found, has to be a value that's found in the other table. So you have 4, 3, all right? If we only have 4 faculty members in the faculty table, then you should not see any values other than 1, 2, 3, or 4 in this table, because it is a value taken from the other table. Now, foreign key is what implements relationships. All right? So in the drawing, this is the conceptual design. Another way of calling that is model. Okay, it's a model, right? And like you have it's like a blueprint for a house. If you have the blueprint for a house, you can't live in it, right? Unless you turn yourself two-dimensional, which is still beyond today's technology. So this is like a blueprint. It's a set of instructions on how to build something like this. This is the actual database. Right? So similarly, we have PK, and then of course we have PK and FK. A lot of concepts in one day. What do you think? Yes.
So the for ID is the field that is present in both tables.
Yes. The course ID in this case. It's a field that's found in both tables. So that's actually it's a repetition of an existing value, right? In fact, the value 1 here is repeated a lot of times. But that's okay. That's redundancy that's necessary. It's necessary because we want to be able to implement relationships between the tables. Without that kind of repetition, you can't implement relationships. However, you don't want to repeat the name and all of the other fields associated with the course, right? You don't want to do that. That information shouldn't be repeated, such as the names. You want the name for a faculty member to be only stored in one place in the entire database. Did you have a question? Okay. Yeah.
Do the other fields that aren't primary key or the foreign key, do they have a name, a specific term?
No, they're just other. Yes, they do. Got secondary keys and indices, but we're not getting into those right now. We just call them other attributes or fields.
Can a primary key in one field be a foreign key in another field?
Always. That's a good question. I should have mentioned that. The foreign key in the table is always, okay, the foreign key in the table is always the primary key in the related table. Good point. Okay. That's something that you can actually have tattooed. Okay? Because it's not going to change whether Obama stays on or Romney gets elected. Okay? Not going to change that. That's the beauty of SQL. I mean, we're not affected by politicians. You guys are all going to vote, right? So, once again, I'm going to repeat that. The foreign key in the table, such as course ID, is the primary key of the related table. Anything else? Okay, we're going to come back to this, but before that, I would like to go through an access demo, the stuff that you need to do in your assignment. Here is the second assignment. And it's 30 points. It's due Wednesday next week. So it's due in a week. But you can finish that very, very quickly, I think. You're asked to create the database in figure 310 on page 94 in Microsoft Access. Your database must meet the following requirements. You must make sure that all the PKs and FKs are properly defined. Do not allow delete cascade. I'll talk about that. Whenever possible, you must define lookup tables for FKs. Okay. Yeah, I will talk about that. Populate the tables with the given data. So just on that page, 94, they have provided data for you. Create a form with a subform. I'll tell you how to do that. It's really easy. That allow you to browse the employees by job description. So if you say, for example, I want to look at all the mechanical engineers or all the managers, you could do that. And nothing to turn in terms of printed materials. That's the assignment. And next, I'm going to go through an example that's almost exactly the same as what you have to do in the assignment. This is the only Access assignment in this class. Okay, so we're not going to do Access anymore, because Access is not a real database management system. It's just a toy. So you may want to dwell on the assignment and savor each moment, because you're not going to have it again. All right. So, access. I imagine you have all been exposed to access. That's why I require 300. And this, we're going to go to File and say New Database. You say blank database. And then you're going to save the database. Going to save database, and the database was saved. Date is 18. The database we're going to do is on page 67. If you turn to page 67, we have a database example. Now, we have a database that has a customer table and also an agent table. I want someone in the class to explain to me what kind of relationship exists between these two tables. Okay. The gentleman here in the front.
It is one-to-many.
One-to-many. Why? Can you explain?
Yeah, because an agent's going to have more than one customer, but customers only going to have one agent.
That's correct. It's a one-many relationship, and it is a one-many relationship. You always have to explain it this way, especially on the first test. It's a one-many relationship because each customer may have one and only one agent, but each agent may have more than one customer. The fact that some agents may not have any customers, right, does not violate the one-many relationship constraint, all right? Please keep in mind that it's a one-many relationship because it allows an agent to have more than one customer. It's a one-many, one on the customer side because each customer, one on the agent side, because each customer may have no more than one agent. A customer that had just come in, for example, may not have any agent, right? So it's fine for you to be without an agent. But if you have an agent, you can have an agent, but you may not have more than one agent. That's why it's one-many. So as you can see, it has a lot to do with the business rules, right? So the company you work for really determines whether it's a one-many relationship. So that's why I said, first day of class, when you look for a database job or look for an Oracle or SQL job, they always want, along with that, some industry domain experience, such as human resource, right? Because you'll be working with the human resource database. If you don't have it, you will acquire it, right? And then of course you become really valuable. Okay, it's not just your technical knowledge and skills, but it's also your knowledge of the business. So that's why we think we have a good major, because we have technical components and we also have business components. All right. So we're going to create a customer table. So click on Table and click on View, Design View. And this table is going to be called Customer. And now, in Access, they give you this auto ID thing which we're going to use long integer, right? And this will be custom ID. And you know how to set a field as primary key, right? Make sure the field is selected. If you turn it off, right, now it's no longer a primary key field. And you click it, now it becomes a primary key. We're just going to have two fields, customer ID and customer name, plus the foreign key, which is the agent ID. And agent ID, of course, we haven't created the agent table, but we're going to use long integer as well. So make sure the type, data type, have to match. It doesn't have to be called agent ID, as I did here, right? It's chair ID. I call it chair ID, and in the primary key table, it's called the faculty ID. It's all right to call them different names, but the type, data types do have to match. Otherwise, you get an error message. So we have defined that table. I'm going to close it and save it, and then create another table. And this time, it's going to be the agent. And similarly, we're going to use the long integer and call it agent ID. And have agent name. Say yes. All right. Now, the tables have been created, and now we are going to create the relationships between the two tables. So you go to Tools, you go to Relationships, and you add the tables whose relationships you're going to define. It's very simple, right? And then, to create a relationship, what you do is that you drop the primary key onto the foreign key. So you drag that and drop it onto, right there, agent ID. And then this pop-up window will show up saying, indeed, you want to relate these two fields, and you want to say enforce referential integrity. We'll have much more to say about this. What it means is that you may not enter a value into the foreign key table that doesn't already exist in the primary key table. In other words, you may not assign someone to be chair of a department who's not already a faculty member in the faculty table. If the person is a faculty member already, but not in the faculty table yet, then you may not assign him or her to be the chair. So you have to enter the person into the faculty table first, and then he has a primary key value, right? Faculty ID. And that faculty ID then can be used to, of course, assign him or her as a chair. Does that make any sense at all? I tend to trap my students by giving you easy stuff in the first 2 weeks, by being extra nice. And but the class is going to get really, really intense. Okay? And I have warned you a few times. So you want to stay with the class, preferably a week or two ahead of the class. You need to cancel all time-consuming social engagements for the rest of the semester. Girlfriends, boyfriends, stuff like that. I know girlfriends are time-consuming because I've been through that. And I also know that boyfriends can be time-consuming because my older daughter went through that. And just almost consumed her. Not good. All right. Now, cascade update, I recommend that. What it means is that if you change the faculty ID, who happens to be the chair, what it does is that it cascades the change throughout the entire database. So if Barker, for example, his ID is 4, right? If for some reason we need to update that, we need to change that to 666, for example, right? Then if you have checked cascade update, then the change will be propagated throughout the entire database. You taking Marcus' class? Have you taken Marcus' class? No? Congratulations. The guys are doing. Okay, so, but do not do cascade delete. Because if you do cascade delete, if for some reason Barker is removed from the faculty table, right? All the related records will be removed. In other words, the CIS department will be removed. That certainly would be the intention, right? Or if the agent is removed, all the associated customers will be removed from the database, along with the agent. That's what cascade delete means. That's why in the assignment, I don't want you to check that. So you have now created a relationship. It's a one-many relationship. And that's access way of saying one-many. And we have to get used to this year's way of saying one-many. It's much more expressive, and I'll show you why. But here, of course, we'll just live with that for now. It's one. Right? It's one-many because each agent may have 0 or more customers, and each customer may have 0 or 1 agent, and no more than 1 agent. So we close that, and you save it. Now, if you recall, in the assignment, I would like all the foreign keys to be defined as a lookup table. So we're going to have customer 1, and customer 1 is going to be Mike, and we'll assign the agent later. And customer 2 is going to be Seth. We have 2 Seths in the class. Customer 3 is going to be Lauren. I think we have a Lauren in the class. And no agents are assigned, please note. Right? And but you can assign an integer right here to indicate which agent you want. But if you assign, let's say, for example, 2 here, right? What do you think will happen? There's no error. That's correct. So we move to the error would show up if you move to the next row. It says you cannot add or change a record because a related record is required in the table agent. Because the agent does not exist, so therefore it may not add the agent. That's what enforced referential integrity means. Remember, when we create a relationship, there's a checkbox called enforced referential integrity. If you didn't check that, then you'll be allowed to add the agent, even a non-existing agent. Okay. So you say, okay, and delete that. Now it's happy. So we close that and go to the agent table and add a couple of agents. So 1, first agent is Barker. 2, second agent is Rodder, and 3, third agent is Wright. Okay, and so we close that. Now, you open the customer table and you go to the agent. Now you can add, say, for example, agent 1 for Mike, and that's fine because agent has been created. But this is not very helpful because if you look at this, how could you remember the names, the IDs of the agents? Right? You can't. It's difficult. So in most cases, most applications that you use, they actually give you the names of the agents, right? Or they give you meaningful choices. So that's what we're going to do. So you turn, you go to View and you go to Design View, and you click on the Agent ID field. That's the field that we want to define as a lookup table. And you go to Lookup, and you go to this drop-down box, and you change it into Combo box. In other words, we want the available choices for the Agent ID field to be a list of the agents in the agent table, but showing the names of the agents. That's the objective. And it's really easy to do. You go to row source, in other words, where the source of information is coming from, and click on the dots. And we know that the information is to come from the agent table, and so we say add and close. And we select both fields, just double click on the field, and it will be selected. Now, when you're selecting an agent, it will probably help if you, of course, have the names listed in alphabetical order, right? So we choose that, and then we say close. And it'll ask you to save, you say yes. So essentially, it automatically creates a query. But you don't have to understand exactly how the query works now. But you know that the first field in the query is agent ID. That's what this refers to. In other words, the first field, the bound column, is the foreign key, right? You want the agent ID to be the foreign key. So you say 1. If you set 2, then of course you get an error. Column count, there are 2 columns because we selected ID and name from the agent table. No headings for the columns. Column width, we don't want to show the ID field, so we give it a width of 0. But we want to show the agent name, so we give it a width of 1 inch. I think it's about 1 inch, something like that. So now, if you save this, say yes, and open it again, all right? Now it shows the name of the agent rather than the ID of the agent. But please note, what's actually stored in the database is the ID, not the agent. Making any sense at all? You understand? Okay. So now, if you were to choose an agent for Seth, you have the access, of course, of choosing names from a list of names. We want you to note one thing that could be confusing, and that is, as a foreign key, it doesn't have to be unique. Right? As you can see, Barker is agent twice. Even though Barker is an agent only once in the agent table, because there he has to be unique. But here he doesn't. What do you think? Questions? So, close this, and I will post this as an example under examples, under course documents. Some of you may not know that. So if you go to course documents, as you can see, I have PowerPoint presentations, and that's a folder. I'll post the examples by date. Today's date will be, of course, let me actually do that for you so you can see. All right, so build content, I'm going to build file, and the name is access example. I think I saved it. All right, so it's there. You can go check it out. But this is where lots of the things will be posted, and this is the SQL Server installation. You may want to look into that soon. We won't have a serious SQL Server assignment until probably sometime late February. But that's not a promise. We may do it earlier. So those are things that you can read to see if it will give you any help. So you think you can do the assignment? So now we're going to go to the slides. And so a lot of the concepts that we just went through will be summarized, and we're going to go deeper into some of these concepts in the slides. I've posted the slides, and that's a good way for you to get an idea, a rough idea of what the chapter is about, and also a good way to start your review. To really understand the materials, you have to read the book a few times. One reading is not sufficient. So once again, chapters 2, 3, 4, I think, those chapters focus on modeling. And we fuss about modeling, again, because of the discrepancies between how we operate as humans and how machines operate. This huge gap needs to be filled, and they're filled, among other things, by models. But modeling is an adventure. It's fun, but also it can be very frustrating. If you want to be in the field, most of you are going to do some modeling of some sort. And it is a difficult field to be in. Modeling usually is part of the process of building an information system. And if you recall, an information system is what? More than just the programs, right? It is also communications, people, procedures, and of course, to us, it's also databases. So we're going to be focusing on, of course, database modeling in this class, but the principles can be applied to a lot of other types of modeling. So what happens, of course, is that you have perceived need. That is, why do you build an information system, right? Because of the change in business, because of the perceived need to automate certain business processes, they say, okay, we need to build an information system. And of course, if you want to build an information system, you want to make sure that it's feasible, right? So we do a feasibility study, saying, indeed, we can do this, first of all, is there money for it? That's the most important thing, right? If there's no money for it, what do you do? As a company, sometimes you borrow money, right? This morning, an oil and gas company in Canada, one I wanted to buy, but I'm so glad I didn't buy, decided to have a shares offering. So they sold, I don't know how many shares, but they were able to collect about $300 million as a result of that. And as a result of that, the share price had dropped by about 10% or so. So I may buy now that I know it's dropped so much. And they use the money for capital expenditure, right? And that's another way of saying, I want to build things. I want to maybe do more explorations, drill more holes, right? You know that this country has an abundance of gas, natural gas. Natural gas price has dropped to, what, $2 something. Okay, it was $12 a few years ago. All these shale gas in the northwestern part of the Midwest. And natural gas is about $10 a unit in Asia and Europe. So you see the huge price discrepancy. But it's difficult to transport gas, you know. But they have come up with a technology to liquefy gas. And there's a company called Liquefy Natural Gas, LNG, Liquefy Natural Gas. That company is building a port in the West Coast. So U.S. will be a net energy exporter pretty soon. So much gas, right? Might as well make use of it. All right, so that's something that's coming, I think. And see the oil price is about $100 today, and the natural gas price, huge gap. Something has to happen. The oil companies, of course, are blocking policies to use gas. Why? They have an interest to keep the price high, right? So they have a lot of money to influence the politicians. And the politicians, the politicians, they're human, right? They have need to feed themselves, and that drives everything else. You're hungry, you do strange things. All right, so coming back to this, you have a perceived need in your business, and so you do a feasibility study, right? And then, of course, you gather requirements, right? Now you say, assuming the feasibility says to go, you gather requirements. And once you have gathered the requirements, what do? You do requirements analysis. And based on the results of the analysis, you design. And based on the design, you implement. And after you have implemented the system, what do you do? What do you do after you implement the system?
Test.
Huh?
Test.
Yeah. We'll say test. We get it. What else? After that?
Maintain.
Okay. You deploy first. But yes, maintain. Okay? You deploy. And of course, maintain. Okay? Now, I have not seen a single case where you have a real system that could be done without human involvement. Right? When you have humans involved, it means a decision. Right? In position. Right? It happens all the time when you need human communication, right? How many times have you told your girlfriends that you love her? And how many times has she asked you, do you love me? Right? So, what happens is that every step along the way, you have loss of fidelity. Okay? So, I'm pretty sure you have seen this. You have seen an information, maybe you haven't seen this because you haven't worked at a company, in a real job. But you build a system, and you present it to the users, and the user said, this is not what I told you I wanted. Okay. And that's the most scary thing an information systems professional would hear. But they hear it all the time. Right? This is not what I want. So why? Because when users present their need or requirements to information system professionals, they may not correctly represent what it is they need. Right? That's already one source of misinformation. And then, of course, as a system professional, you're not trained in the field, right? So you may hear it wrong. Okay? And the day you put the requirements down, you may not have slept well the night before. So you misrepresented some information. And the person who designed the system usually doesn't collect the requirements. So the person, of course, may read your requirements incorrectly. It's not what you intended. And on and on and on. So by the time it actually gets implemented, it's totally different from what was the original intended. So that's why we now have agile programming. Right? People are fed up with having to wait for years for a system to be implemented. So you may want to pick up on that. GE is implementing agile programming company-wide, worldwide, which means all the GE installations will look into that. So in our class, we're going to focus on modeling for databases. In other words, our focus is on modeling data. And you already had a taste of it today, in that the technical constructs are just very few, right? I mean, you may you may feel overwhelmed at times by the technical constraints in this class. That's because you're exposed to it for the first time. But most importantly, and this is going to be true throughout your entire career, understanding the business requirements is the most important part. And as I tell my students, beginning of the class, at the end of the class, technology is the least of the projects. But you're going to be struggling with technology throughout the entire class. After that, please note, technology is the least of the problems. People can manage that process well, make a lot of money, an ungodly amount of money. You know how projects today are, right? They're expensive. They have $10 million, larger projects, $30 million. They want to hire someone that's good managing the process. How do you become a good manager? Become a good manager by understanding the different technical aspects. Database design is one important aspect. Right. You've been lied to your entire life through the U.S. school system. They've been telling you that study is fun, learning is fun. Learning is not fun. It's painful. All right? I've warned you many times. Learning is very, very painful. Okay. All right, I'll see you next week.